Something to think about here that's reasonably common is that you end up with an infinite loop, meaning like maybe you are some sort of animal that is always thirsty. Maybe you have something wrong with you. You're always thirsty. Maybe you have coded yourself wrong. You will never say that you're not thirsty. If you start this, it will just keep going forever.
What does that do for the GPU on a mobile phone?
The GPU has nothing to do with it. But what it will happen is that eventually the operating system or the whatever processing will understand that, hey, this is ridiculous. I'm just gonna like die here, depending on what you're doing in here.
Yeah.
Or it's just gonna keep going until you stop the program, or until the whole phone or computer crashes.
Okay.
Okay. There's other control statements.
Okay.
If you.
No, I think this is helpful for when I go in. The status of my options is ridiculous. I have a bunch of options, and I like to complete everything that I do.
Yeah.
So I have. Now my next step is to do what someone suggested on my post yesterday, which was to do these tutorials called Roll the Ball, and it's some very straightforward tutorials on Unity that I hadn't seen. And so he said, get in there, and then you'll start to see how they're using code in the examples, and so this will help me read it.
Right, exactly. And if you see something like, hey, this looks like a control statement, but I don't know what it is, you can Google like C# control statements, and then you'll find all the things.
Okay.
Okay. So, methods or functions is a way to encapsulate like things that should be always done together.
Like washing dishes, cleaning counters.
Now, washing dishes, for example. Washing dishes includes a bunch of things.
Yeah.
Right? Turn on the water, scrub the thing, like put it away. Like that's a bunch of stuff that's happened.
Empty garbage disposal.
Whatever. All those things. So there could be a method called empty dishes. That's one way of grouping things together so that you don't have to rewrite all those steps. It's good. All those steps every time you want to do something like that.
Okay.
Another way to group things together is something called classes.
Okay.
There are a variety of ways of structuring code. One way is to use it's called object-oriented programming. That is to use something called classes, and that's basically treating the stuff in your program as things that you can
give attribute to.
Have attributes and methods on. So, for example, in my example here, it's a dog.
Okay. What is this word you wrote here?
Encapsulate.
Okay.
Variables and methods that are somehow logically connected to each other. So, for example, in my little very simple class here, it's a dog. Okay, what is a dog? Maybe it has a name, maybe it has an owner, maybe it has an age, bunch of other stuff probably, but I don't want to write anything down. And so this is a class of dog. It has these things which are variables. Okay, depending on what dog it is, these are different.
Okay.
When you want to use a dog, you basically make a dog, construct a dog. That's what these things are. They are constructors. They look like methods, except they have no return value.
Okay. When you say make,
I say stick a dog in my system.
Okay.
Like I want to have a dog to do stuff with. You make a dog. You construct a dog.
How do you do that?
I'll show you.
Okay.
So, but you use something called constructors, and what that is like when I create a new dog, what is its initial state going to be?
Okay.
So, for example, if I have a constructor that does nothing,
then you don't have a dog.
Then I have a dog, but it's undefined what name it has. It's undefined what owner it has. It's
Oh,
undefined.
are these all constructors?
No, these
No.
are all variables.
Variables.
On
but
the dog.
This part.
This is the constructor.
Okay.
This is a constructor that does nothing.
Okay.
So if I were to create a new dog using this constructor, it would have no name, it would have no owner, and it would have no age. Or more specifically, it would have the default for a string for name, it would have the default for an owner for the owner, and it would have the default for an int for age.
Mm-hmm.
The default for an int is 0. So this dog would be 0 years old. The default for this thing, which is a class, would be null, meaning that it's nothing. The default for a string, depending on language, I don't know what it is. Maybe it's empty string, or maybe it's null, or something like that. This, after that, you can have multiple.
I'm super interested in hearing how you make constructors.
Yeah, this is a real constructor that actually does something.
Okay.
Starting from here, ending there.
Okay.
Similar to a method, it takes in parameters.
Mm-hmm.
So input parameters.
What's the difference specifically as the difference between parameter and variable?
A variable
Parameter is like...
Parameter is this thing that you stick into it.
Okay.
Variable is something that you have, that you are, or whatever. So, in this case, a dog.
Mm-hmm.
I want to create a dog, and I want to, at the moment I create it, I want to give it a name, an owner, and an age.
Mm-hmm.
So I created a constructor that for input parameters have a name, an owner, and an age.
Mm-hmm.
Okay, so then inside the constructor,
Mm-hmm.
I can set these things to be the same as these things. So basically, in my constructor, I can reference to this object that I'm creating.
Mm-hmm.
So this dog that I'm actually creating right now, that dog's name is going to be whatever you pass in as name here. That dog's owner is going to be whatever you pass in.
That's what you're saying here and here.
Yeah.
Yeah.
So this dot name equals name. That means that this dog dot name, which is that name, equals name, which is that name.
Would all of this code be together, or are these two different examples?
No, this is all together. From
Okay.
here and onwards, it's all
Okay.
the same thing. It's the class
Okay.
of dog. Okay. So this
Why wouldn't you put all this stuff just right in there? You would.
You would.
Okay.
Like you can have different types of constructors.
Okay.
Maybe you don't when you create a dog, maybe you don't know maybe it doesn't have an owner when you first create a dog. So then you have maybe a constructor that is only name and age. And then at a later stage you assign an owner to that dog or whatever you want to do.
Okay.
Maybe it doesn't have a name when it's born, a dog, and then you give it a name a year later. Now, who knows? So you create your constructors to reflect how you're actually going to be creating these objects. So these are just examples.
And you call these variables?
Yes.
And
These
what's
are
the
class-
parameters?
These are parameters to the constructor.
Okay.
So variables.
Is there an explanation why you list the variables in the order before you do the constructor?
Yes. It's just basically like
Giving a heads up to the...
basically you want to order your classes in a sane manner so that you always do the same thing and everybody does the same thing so that it's easy to read. And the general way to do is that the variables come first, then comes the constructor, and then comes methods.
Okay.
That's just how it's done.
This is with regards to classes.
Yes.
List variables, constructors,
Yeah. Methods.
and methods. Okay.
So methods. I've done some super simple methods here.
Yeah.
They don't really do much. For example, maybe I want to know what the name of this dog is. So I have created a name as a method that's called getName. It returns a string. So basically all that I do is return this .name. Okay. Similarly, I can do one that actually it should be like this. I want to set the name. I want to give this dog a name. So I have a method.
And yeah, why did you do void?
I'm going to explain that. This returns something. This returns a string. That's what that is. This is just saying like, hey, this method is going to give you a string.
Okay.
This method, set name, is not going to give you anything because all you're doing is setting the name for the thing.
Gotcha.
Right? You don't expect anything back from that. You're
Right.
just saying, set the name to this that I'm giving you.
So you have to say void?
Yes. That again, it depends on the language.
Okay.
This is a pretty common way
Okay.
of representing it. So set name, the input parameter is a string name. So similar to what I did in the constructor here, this dot name, meaning that this dog's name is going to be name, which is that.
So where is the most critical command line, if that's the right word? No.
I don't know.
For where his name is. If his name's Bobo.
Yeah, that's where this is.
You wrote Bobo there.
No, I didn't write Bobo there. This is the name. Name is a variable that holds the name.
Yeah, but in the code, where would you actually say, I know the name of this particular object is going to be called Bobo versus Knuckle?
Yeah, depends. Either if you know that it's going to be called Bobo when you make this dog, you put it in here.
In the constructor.
If you don't know, or if you
and
want...
you would write it here.
Yes.
Okay.
No, you wouldn't write Bobo here.
Yeah, where do you write the proper thing?
All right, I'll show you. We get to that here. So, if you know at the beginning of what your dog is called and who's the owner is and what the age is, you would do something like this. Dog, my dog. That this is saying what kind of a thing I'm making. What this my dog is going to be.
That's up to you to decide, right?
Yeah, so I say I'm creating a dog, so dog, my dog. Okay? This is a class, this is an object. An object is a specific instance of a class. So not a dog, but my dog.
So if there were 4 dogs, it would be
dog 1, 2, 3, 4. Or you can call them Bobo and Fluffy, whatever you want.
Okay.
Doesn't matter. So my dog, and again, this is language dependent.
Specific, yeah.
So how you do this. I don't know how it's done in C#.
No.
Probably pretty similar
It's
to
similar.
this. So new dog, that means new means that you're using a constructor. You're creating something new.
Okay.
It also means that you're reserving a bunch of memory in the computer.
Okay.
In some languages, when you create something new, you always need to make sure that you destroy it when you're done with it. Otherwise, you're gonna get something called memory leakage, meaning that if this table is my computer's memory, I stick my dog here, and then I go on my merry business, and then I'm done with my dog. I need to take my dog out. I don't know what C# does.
Yeah. You had to kill stuff in lingo.
Yeah. C and C++, for example, you have to have something called basically you have to kill it after you're done. I don't know exactly. I don't remember how to do it, but it's the opposite of this, more or less.
Okay.
So the object, which is a specific instance of a dog, you use a constructor to create this instance of this dog. So dog, the constructor, which had 3 inputs, 1, 2, 3. It was name, owner, and age. So in this case, I am creating a new dog. His name is going to be Fluffy, his owner is going to be me, and his age is going to be 5.
Okay.
So after this, I could say, like, my dog.getName, which was my method here.
Yeah.
And that would return Fluffy.
Okay.
Okay? Because I've said that this dog's name is Fluffy. So if I say getName, you would get Fluffy back.
Okay.
Okay? If I want to change his name, maybe I don't like Fluffy. I'm going to call him Dr. Snuggles instead. So then I say my dog dot set name, which was this thing. It doesn't return anything,
Right.
but it expects that you provide a name.
Okay.
So I provide the name Dr. Snuggles.
Okay.
So now if I were to, after this, were to look into my dog, I would say that a name now equals Dr. Snuggles.
Okay.
But owner and age is still the same.
Okay.
It's me and 5.
Yeah. And so you'd have all that code just for saying the name of a dog and his
Yes.
owner and his age.
Yes.
All that code.
All that code. Obviously, if this was all you wanted to do, you wouldn't probably use a class even.
Right.
The point of doing
Showing the
this
logic.
is to make sure that when you want to do complex things, that you can do it in a way that's easy to read and you can actually reuse without having to write the same thing over and over and over and over again.
Refactoring.
Refactoring means that you're taking something and changing it.
Okay.
All right.